Introduction to CERN's latest discoveries. Within the shadow of Geneva, beneath the surface of our world, exists a marvel of human creativity, and a potential precursor to destruction, the Colossal Hadron Collider, LHC. This apparatus serves as an unparalleled tool for specialists, allowing them to investigate subatomic particles and uncover the enigmatic God particle, the Higgs boson. Distinguished physicist Brian Cox has offered a chilling explanation that has stirred mixed emotions among scientists, prompting them to examine the fundamental components of matter and scrutinize the very essence of spacetime. However, the immense energies involved in these experiments also pose significant dangers, both recognized and unrecognized. One of the foremost concerns surrounding the operation of the Massive Hadron Collider is the potential generation of miniature black holes or other extraordinary phenomena that could yield unpredictable outcomes. While theoretical models suggest that any such black holes would be fleeting and pose no threat to Earth or its inhabitants, the risk of inadvertently creating horrors beyond our control remains unsettling. Furthermore, the vast scale and intricacy of the experiments conducted at the Collider necessitate rigorous safety protocols and oversight to mitigate possible hazards. The international community of researchers and scientists involved in the Collider's operation is acutely aware of the imperative to prioritize safety and ensure that all experiments are performed with the highest degree of caution and responsibility. The Large Hadron Collider, with its ability to astound and challenge our comprehension of reality, is not merely a triumph of modern engineering but also a crucial hub of contemporary particle physics and cosmology. Its primary goal is to investigate the fundamental particles that constitute the universe, carrying profound implications for our understanding of existence. The LHC allows scientists to replicate conditions just moments after the Big Bang, offering a remarkable opportunity to study the Higgs boson and other essential particles. The Higgs boson, often termed the God particle, was postulated in 1964 by Peter Higgs and colleagues as a vital element of the Standard Model of particle physics. This model delineates the fundamental forces and particles that compose the universe. The identification of the Higgs boson at the LHC in 2012 validated the existence of the Higgs field, an invisible field that imparts mass to other particles. This finding marked a significant achievement, confirming decades of theoretical exploration and enhancing our comprehension of the universe's hidden structure. Nevertheless, like all major scientific pursuits, the quest for knowledge at the LHC is not devoid of potential risks and ethical dilemmas. The energies involved in particle collisions at the LHC are staggering, and the likelihood of generating new forms of matter or instigating unforeseen reactions cannot be entirely dismissed. Some scientists have speculated about scenarios where high-energy collisions could create small black holes or other unusual particles, raising alarms about the potential consequences of such occurrences. While the majority of experts deem these risks to be exceedingly remote, the very essence of scientific inquiry entails venturing into the unknown. Brian Cox's assertion, emphasizing the possibility of recreating a miniature Big Bang within the LHC, underscores the immense significance and possible dangers of this research. The Large Hadron Collider epitomizes the zenith of contemporary scientific endeavors. However, its extraordinary capabilities also ignite a fundamental discussion about the limits and responsibilities of scientific exploration. The Collider, through its design and functionality, seeks to address fundamental questions regarding the universe, yet it operates at the periphery of human understanding and technological proficiency. This intersection provokes substantial inquiries about the nature of science, scientific risk, and the ethical ramifications of such advanced research. One of the most exhilarating aspects of the LHC is its capacity to simulate conditions shortly after the Big Bang, providing captivating insight into the early universe. This replication allows scientists to investigate particles that existed during the universe's early phases and examine phenomena that would otherwise be challenging to access. By recreating these extreme conditions, researchers can evaluate theoretical predictions and refine models of particle physics. For instance, experiments at the LHC have the potential to scrutinize the properties of hypothetical dark matter particles, which are believed to constitute a substantial portion of the universe's mass but remain elusive to direct detection. The pursuit of understanding dark matter is propelled by its profound implications for our comprehension of the universe. Currently, dark matter is inferred from its gravitational effects on visible matter, but direct detection remains problematic. The LHC's experiments aim to tackle this challenge by attempting to generate dark matter particles in the laboratory. If successful, this could revolutionize our grasp of the universe and potentially lead to groundbreaking discoveries and insights. Such advancements highlight the LHC's role as not just a scientific instrument, but also a catalyst for transformative discoveries that could reshape our worldview. Another captivating area of inquiry involves the strong force, one of the four fundamental forces of nature. The strong force binds protons and neutrons within atomic nuclei, and comprehending its behavior at elevated energies can yield insights into the fundamental structure of matter. The LHC's ability to investigate strong force interactions on an extreme scale enables scientists to explore the dynamics between quarks and gluons, the fundamental particles that mediate the strong force. These investigations could lead to a deeper understanding of nuclear physics and the forces that govern atomic behavior. The technological progress fueled by the LHC extends far beyond particle physics. The collider's complex systems for detecting and examining particle collisions have sparked innovations in computing, data analysis, and sensor technology. For example, the development of the World Wide Web was originally envisioned as a means for researchers to exchange data from particle physics experiments at CERN. Today, this technology has revolutionized global communication and information sharing. The advancements in computing and data management prompted by the LHC have had a widespread effect across various fields, demonstrating how significant scientific research can drive technological advancement. However, operating such a powerful device necessitates strict safety protocols and ethical considerations. The possibility of unforeseen outcomes, such as the creation of new or unusual particles, requires a careful assessment of risks. While theoretical models suggest that the chance of catastrophic events is extremely low, this possibility cannot be entirely ruled out. Temperatures colder than outer space, just 1.9 Kelvin above absolute zero. This extreme cold is necessary to enable superconductivity, allowing the collider's massive magnets to function without electrical resistance. Such precision engineering illustrates the sophistication of the LHC and the meticulous attention to detail required for its operation. As these high-energy proton beams collide within detectors like ATLAS and CMS, they momentarily recreate the conditions of the early universe, allowing scientists to peer into the quantum realm and probe the building blocks of reality. These collisions not only confirm the Higgs boson but also continue to yield data that challenge existing theories and hint at new physics beyond the standard model. This search for new physics is where the LHC becomes more than just a research instrument. It becomes a gateway to potential paradigm shifts. Questions surrounding supersymmetry, extra dimensions, and quantum gravity remain unanswered, and the LHC stands at the forefront of attempting to resolve them. Some theories suggest that gravity's relative weakness compared to other fundamental forces might be explained by additional spatial dimensions, possibly curled up at subatomic scales. Detecting evidence for such dimensions would revolutionize our understanding of the universe's structure. Simultaneously, the LHC's upgraded phases, like the High Luminosity LHC, HLLHC, project, are being developed to significantly increase the number of particle collisions, thereby boosting the chances of discovering extremely rare phenomena. This ambitious undertaking reflects not only scientific ambition but also global cooperation, involving thousands of scientists and engineers from around the world working together in pursuit of knowledge. Yet with such immense power and ambition comes equally profound responsibility. Public concerns, often amplified by media speculation, have questioned whether experiments at CERN might inadvertently trigger cataclysmic events, from creating Earth-consuming black holes to opening hypothetical portals to other dimensions. While such fears are largely unfounded according to current physics, their persistence underscores the need for transparent communication between the scientific community and the public. Indeed, CERN has implemented extensive safety reviews, including evaluations by independent scientific bodies, all of which have concluded that the LHC poses no threat to humanity. Theoretical and experimental evidence suggests that even if miniature black holes were produced, they would decay rapidly through a process known as Hawking radiation, rendering them harmless. Still, the philosophical and ethical questions linger. As humanity reaches ever closer to the fabric of the cosmos, are we prepared for what we might find, or unleash? Should there be boundaries to scientific exploration, especially when the outcomes are not fully predictable? These are not just questions for physicists, but for society as a whole. In the end, the Large Hadron Collider represents both the brilliance and the boldness of human endeavor. It is a cathedral of science built not of stone and stained glass, but of magnets, vacuum chambers, and data. It reflects our deepest desire to know, to peel back the layers of reality and uncover the source of everything. And in doing so, it forces us to confront not only the mechanics of the universe, but also the responsibilities that come with wielding such knowledge. As CERN continues to push the boundaries of the known and venture into the unknown, one thing is certain. The story of the LHC is not merely about particles and fields, but about human curiosity, unity, and the quest to understand our place in the vast cosmic order. Outer space. The design of the LHC is an engineering marvel. Operating deep underground and shielded from cosmic radiation, the entire ring is cooled to temperatures below those of the vacuum of space. This is essential for the superconducting magnets to function effectively. Collisions occur at 4 points along the accelerator ring, each corresponding to one of the 4 major particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors capture the aftermath of collisions, enabling scientists to sift through the debris in search of the elusive Higgs, a particle crucial to understanding the universe's structure. The LHC is not just a scientific instrument, it is also a testament to human imagination and ambition. It embodies our quest for knowledge and our desire to comprehend the fundamental forces that shape our universe. Yet, as we push the limits of understanding, we must also consider the moral and existential questions that arise. The ambition to recreate conditions similar to the Big Bang carries profound responsibilities, and the pursuit of knowledge should never come at the expense of safety. The journey of scientific discovery often involves moments of awe, wonder, and the unknown. The Large Hadron Collider, LHC, serves as a testament to humanity's unyielding curiosity and the drive to unlock the deepest secrets of the universe. Despite its immense potential to reveal the nature of matter and the origins of the cosmos, the LHC also calls into question the balance between exploration and caution. As we delve deeper into the microscopic world, it becomes evident that the LHC is not just an engineering marvel but a symbol of the intricate relationship between science and society. CERN's vision extends beyond the LHC, with ongoing efforts to explore the unknown realms of physics, such as the quest for a unified theory of everything. While the LHC's experiments focus on particle interactions at unprecedented energy levels, the goal remains to answer some of the most profound questions of existence. How did the universe begin? What are the fundamental forces that govern everything? Could there be other dimensions of existence? These questions, though theoretical, push humanity's scientific boundaries further than ever before, allowing us to dream of solutions that once seemed beyond reach. Yet despite these breakthroughs, the scientific community must continually address ethical concerns. A significant issue involves ensuring that the LHC's discoveries are utilized responsibly. With such groundbreaking potential comes a responsibility to ensure that the knowledge gained from these experiments does not inadvertently cause harm or lead to unforeseen consequences. As new particles or interactions are uncovered, it is essential that their implications are fully considered and that global governance frameworks are in place to guide the use of this knowledge. The LHC's discoveries could have far-reaching effects on fields beyond physics, including medicine, energy, and technology. For example, advancements in accelerated technology may lead to better cancer treatment options, while understanding fundamental particles may help scientists devise more efficient energy systems. Collaboration plays a key role in the future of the LHC. The project involves a global network of scientists, engineers, and researchers from diverse backgrounds and disciplines. This collaborative spirit is essential for the LHC's ongoing success and for addressing the challenges it presents. As we move forward, it will become increasingly important to foster international cooperation in scientific exploration. The LHC exemplifies how nations can work together to advance knowledge for the betterment of humanity, transcending geographical and political boundaries. In a world where scientific discovery often occurs at the intersection of disciplines, the exchange of ideas and expertise is crucial for progress. The LHC's role in advancing our understanding of the universe, though profound, is only one part of a larger picture. The experiments conducted at CERN are paving the way for future generations of researchers to take the next step in understanding the forces of nature. As the LHC continues to operate and new discoveries unfold, it will shape the future of science and continue to challenge our perceptions of reality. As we stand on the edge of new scientific frontiers, it's crucial to remember that our exploration should not only seek knowledge but also respect the ethical considerations that come with wielding such immense power. The questions we answer today may shape the world for generations to come. Conclusion and final thoughts. In conclusion, the Large Hadron Collider represents the pinnacle of human accomplishment in scientific exploration. Its vast potential to unravel the mysteries of the universe is matched by the significant risks associated with its operation. As scientists delve deeper into the fabric of reality, it is essential to remain vigilant, ensuring that the quest for understanding is conducted with the utmost responsibility and care. The future beyond the collider. Looking ahead, the impact of the LHC extends far beyond the confines of the underground tunnels at CERN. Its success has sparked conversations about what comes next, not just in terms of machines, but in how we approach the future of science. Already, discussions are underway for the Future Circular Collider, FCC, a proposed successor that would be nearly 4 times the size of the LHC and capable of reaching even higher energies. Such ambition reflects a growing appetite in the scientific community to probe deeper into the unknown, to search for dark matter, to explore the asymmetry between matter and antimatter, and to better understand quantum gravity. Each new advancement opens yet another door, and with it, more profound questions. But with greater power comes greater scrutiny. As technologies become more advanced, public engagement becomes essential. Transparency, education, and inclusive dialogue with society must accompany scientific breakthroughs. The public must not only be informed about what these machines do, but also invited into the conversation about why they matter. Education and inspiration. One of the LHC's greatest legacies may not be its data, but its inspiration. Around the world, it has ignited interest in physics, engineering, and science as a whole. Young students look at the LHC and see possibility, the idea that the world's greatest challenges can be met with intellect, collaboration, and creativity. Educational programs, public tours, documentaries, and outreach events have made complex topics like quantum mechanics and particle physics more accessible than ever. By demystifying the science, CERN helps cultivate a global culture that values curiosity and critical thinking. Ethics in an expanding scientific age. As the scientific frontier expands, the question of ethics grows ever more central. How far should we go in recreating the conditions of the early universe? What boundaries must we set to protect ourselves and the environment from unintended consequences? Ethical science is not merely about preventing harm, it is about responsibility, a duty to ensure that knowledge serves the well-being of all humanity. It requires diverse voices, rigorous oversight, and a shared understanding that technological power must always be balanced by wisdom. A collective journey. The story of the LHC is not just about particles or collisions, it is a story about people. Thousands of individuals, scientists, engineers, technicians, thinkers, from across the globe, united by a common dream, to understand who we are and what the universe is made of. In an age often marked by division, the LHC reminds us of what can be achieved when humanity works together toward a shared goal. It is a beacon of what is possible when borders are set aside in pursuit of a greater truth.